Good morning to one and all. I am Parthiban, working as assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called satellite communication, which is coming under the regulation R 2021. The subject code is CEC 352. I am going to talk about the unit 3, which deals with link power budget. So in the link power budget, we are going to see the example. So how the link power budget has been established and how it has been managed. So what are the things that it is having and all we are going to see. Here the link power budget, particularly the downlink budget, identifies the characteristics of the satellite transmitter, characteristics of the antenna, the path, the receiving antenna, and the expected performance of the earth station receiver. So it contains the elements that select the desired radio signal and demodulates the very useful information. Once converted back to baseband, the transmission can be applied to other processes such as demultiplexing, decryption, as well as D2A conversion. Generally, the downlink is a communication path from satellite to earth station. The signal transmitted by the satellite must travel through space, atmosphere, rain, clouds, and various propagation environments before reaching the earth station. Therefore, the engineers need to calculate whether the received signal strength is sufficient in nature or not. So this calculation is called downlink budget. The purpose of a downlink budget is to provide the information regarding the satellite characteristics, that is the satellite transmitted power, the satellite antenna gain, the satellite EIRP. EIRP is nothing but the equivalent isotropic radiated power. Then about the propagation characteristics that involves the free space loss, the atmospheric loss, and the rain attenuation. Here in the table where we are giving the some of the values, the standard values based on the assumption that we have made during the propagation. So this can be referenced as a text, particularly for estimation that we can use. So the generally the earth station characteristics involves receiving antenna gain, receiver noise temperature, receiver noise sensitivity, and also the system performance that we have to take into account, like received carrier power, carrier to noise ratio, as well as the link margin. So in the table we have given the standard values of estimation based on the computation that is done by means of the International IEEE Association. Then coming on to the downlink budget, the each link parameters refers to the specific piece of hardware or some property of microwave path that establishes between the space and ground. A good way to develop the link budget is to prepare it with a spreadsheet by means of a program. So this permits the designer to include the various formulas directly in the budget so that it avoids the problem of external calculations or arithmetic errors. The commercial link budget softwares are available such as SatMaster Pro, which is a very famous one. This will do the very good job before standardizing the fashion or final value. Satellite link design involves not only the downlink, but it also involves uplink also. So in the uplink also we have to take into account the various factors. That is like the transmitter power, the antenna gain, the EIRP. EIRP is nothing but the equivalent isotropic radiated power, which is nothing but the PT into GT, that is nothing but the transmitted power as well as the gain of the transmitter. So multiplication will give you the EIRP and the microwave propagation path. So in the propagation path, it will have the various losses like free space loss, atmospheric loss, rain attenuation loss, cloud attenuation loss. In the earth station receiver, we are going to see about the receiving antenna as well as about the LNA effects. LNA is nothing but the low noise amplifier effects, as well as about the down converter, which is nothing but the converter of microwave frequencies to the IF frequencies. as well as about the demodulator effects. So these are the things that we are going to see. Lastly but not last, the signal recovery process will also be taken into account. There in the signal recovery process, we are going to see about the demodulation effects, as well as the demultiplication effects, as well as the decryption effects, as well as the DA conversion effects. So these are the things that we are going to take into account. So similarly for downlink, we are going to see about the uplink also. So in the uplink also, there is a specific flux density is required in the satellite. There is a specific power level is also required at the transponder. So we have to calculate the uplink CN ratio based on the dimensions that we are using. So as the smaller dia earth stations have a higher power earth station transmitter is required to achieve a similar satellite EIRP. Interference to other satellite traces due to wider beam width of the small antenna. So uplink power can be used against the rain uplink attenuation. So here is the typical example of uplink budget. So in the budget, we can see the various parameters like transmitter power, waveguide loss, like uplink ERP, like the spreading loss, like the atmospheric attenuation. These are the standard computation that can be done by means of the softwares that we are having. The free space loss, as well as the receiver antenna gain, as well as the receiver waveguide loss, as well as the system noise temperature, the spacecraft G by T value, as well as the received G by T value, the Boltzmann constant, which is a standard value, based on the bandwidth that we are using, as well as the C to N ratio that is also tabulated in the uplink budget, as if like downlink budget. So the very important equation is nothing but the C bar N ratio equation, which is nothing but the carrier to noise ratio equation, which defines the capability of the satellite communication. So which can be depicted both for uplink as well as for downlink. So it involves the parameters like EIRP as well as the G by T, that is gain bar temperature effect, thermal constant, as well as the losses. These factors will be taken into account. The subscript DD depicts the downlink. The subscript UU links about the uplink. So what is the transmitted power is nothing but the transmitted power as minus losses that will be given as the received power. So in the uplink analysis, we can have U as a subscript. In the downlink analysis, we can have D as the subscript. So link power example is one last thing that we can resort for the calculation of satellite performance. So the table presents the detailed evaluation of overall link under the various conditions of line of sight propagation in a clear sea, near clear sky. We have included allocation of interference coming from the various sources, as well as the cross polarized transponder and adjacent satellites also taken into account. So this type of entry is very necessary because all operating satellite networks are exposed to one or more source of interferences. So alternatively, the range margin also calculated, and which can be separately calculated both for uplink as well as downlink, and which will also be taken into account by means of the link power budget equation. So you can see the overall link power budget equation, both uplink as well as downlink, combinedly tabulated in the table with the standard values as well as units from the computation values. So this diagram depicts clearly the required CN value for the propagation. What is the total CN value needed? What is the required total CN value needed? That and all can be calculated very easily in terms of dB. So this is the exact analysis of overall uplink and downlink budget. So with that, I am winding up today, thanking you one and all for hearing my lecture patiently. Thank you.